My name is Malik Blanchard, and this is my soil analyzer robot. I designed this 3D model in Tinkercad to simulate a rover that can move, detect obstacles, and collect soil samples using a servo-powered bucket. In this video, I'll walk you through the full circuit, explain how it operates, and demonstrate its workings using code and simulation. Based on the reading from the ultrasonic distance sensor, the motors will rotate differently. Above 20 inches, all six motors will rotate forward at about 191 RPM. Between 10 and 20 inches, the robot will rotate and scan its surroundings. This is done by rotating the left side motors in reverse at about half of total speed and the right side motors forward at full speed. When distance falls below 10 inches, the robot will reverse. A high signal from A1 will stop all six motors from spinning. This is to stop the rover to collect the soil sample. The soil sample is collected by operating the bucket via a servo. High and low signals demonstrated via the push buttons will rotate the servo. This in turn will control the arm to collect the soil samples. This is the code used to operate the rover via the Arduino. For the ultrasonic sensor, pins 3 and 9 were used for the trigger and echo respectively. For the DC motor, 7 pins were used to operate the 6 motors. I did not use a pair per motor due to there being an overload if more than 7 pins were used. For the servo, pin 13 was used for the input signal, pin 7 was used for the clockwise motion, and pin 8 was used for the counterclockwise motion. For the emergency stop, pin A1 was used. The initial position of the servo was 90 degrees. This can also be known as the home position. This is the initial setup for all the pins for clockwise, counterclockwise motion, as well as the emergency stop, the ultrasonic sensor, and all the motor pins. For the stop, which is used to collect the oil sample, also known as, I named here the emergency stop, a Boolean value was used. When the input is high, it will stop. All of the signals to the DC motors effectively stop in the rover. This is the setup for measuring the distance. It will use the fluctuation between high and low from the trigger and echo, and this formula to calculate the distance based on the time taken by the emitter and the receiver of the signal. For the logic motion, if the distance is greater than 20 inches, motor pin L1 and L4 will both be high. R1 and R3 will also be high. This will cause all 6 motors to rotate forward at full speed. If the distance is greater than 10 inches but less than 20, pins L2, L4, and R1 will all be high. This will cause the left side motors to reverse and the right side motor to operate forward at full speed, causing the rover to rotate and scan its surroundings. If the distance is less than 10 inches, the rover will reverse. For the operation of the servo, the Boolean value was also used. When the counterclockwise button is pressed, the rover will rotate in reverse towards 0, while when the clockwise is pressed, the circle will rotate forward towards 180 degrees.